Welcome to 2021, guys. And that means we got a brand new chapter. So, shouts out to 2021. But on a real note, just because that number changed, that does not mean that this year is going to be any better. So, what we need to do is make sure you're loving people, you're taking good care of yourself, and you're keeping what's really important in mind because we're not promised tomorrow. And I love you guys. And with that said, I hope your last memory of me, if I were to die today, is of that I love you, and that I'm excited for you guys to learn about Chapter 7, where we talk about roots, we talk about the Pythagorean theorem, we bring back geometric mean, we're all about right triangles, and we're going to mix in a little bit of algebra in here. We got perfect square roots, radicals, all that good stuff. And it's radicals that I really want us to focus on today. Let's jump into day one. So, for those of you who had me last year, we didn't really get to talk about this as much as I wanted. Today is going to be Algebra Central. I want you guys to become algebra students for me again, for today and for tomorrow especially. This whole day revolves around this key prerequisite, and it really is. We're talking square roots. So when I want you to think about day one, I want you to think about the term perfect square. Now, when you guys think about that word perfect square, a lot of times what comes to mind is, oh, we're talking about square roots. These two things are connected, and they are. For example, let's pick a number that is technically a perfect square. Let's go 36. So 36 is a perfect square. That means that if you were to take the square roots of this perfect square, we know that normally what we call the principal, spelled like the job, principal roots, normally that would be what? What would you get when you take the square root of 36? Well, you get a principal root of 6. But here's the thing. In algebra, when you take the square root of a number, you actually get two answers. You get positive 6 and negative 6. You're probably thinking, whoa, why is it whenever I take the square root of 36, I get a negative and a positive? That doesn't make sense. Well, that's because, tell me, to get from this back to this, what would 6 squared be? Oh, well, of course, that'd be 36. That checks out. What would negative 6 squared be? Negative 6 times negative 6 is positive 36. So both these can be the answers once you take the square root of a perfect square. Now, in geometry, pretty much from days 3 and on, we're going to think about this as the square root of 36 just giving us 6. Because in geometry, we deal with distance. And we know distance cannot be negative. So in geo, from days 3 and on, we would just talk about the square root of 36 being 6. But for algebra, we're going to be discussing these next couple of days, positive and negative 6. And you can see some breakdowns here. An expression that contains a square root is considered a radical expression. That word radical means anything involving this symbol right here. We're going to come to find out that this could also have a different power. For example, the square root symbol is actually, you may not have known this, that is what's known as the actual square root symbol. We know that we normally write it like that. These are the exact same thing. Whereas this over here, this is a radical to the third power. So this is a radical to the third power. So the number up here dictates the power, and if you don't see a number, we assume it is a square root. So obviously you have issues of what are each of these called. We got radicands, which is just the number underneath the radical, all that good stuff. But what we are going to focus on today, simplifying expressions. Well, we have three things we need to make sure that we follow. Step one, no radicands have perfect square factors other than 1. So no numbers underneath the radical have perfect square factors other than 1. So when we simplify this, we need to break it down so that the only number that is left under a radical is a number that cannot be broken down. So when we simplify, no perfect squares remain. So check it out. Consider this square root. Doesn't have a perfect square factor other than 1. Well, we've got one. I apologize, by the way, for writing this way. That is 175. Is there a perfect square inside of 175? Yes, there is. 25. If you don't know, check it out. Check it out down here. Perfect squares. 25 is a perfect square, and 25 goes into 175. How many times? If you do 25, which is our perfect square, multiply that by, really you could just divide, do it this way, 175 divided by 25, that gives you 7. So in other words, you could split this up into the square root of 25 times 7, all underneath the square root. Well, guess what? You can break this apart into the square root of 25 times the square root of 7. And then from there, we know that the square root of 25, remember up here, with algebra, we're going to get plus or minus 5, and then guess what you have still being multiplied to it? Square root of 7. The square root of 7 has no other perfect squares inside of it other than 1. You can't break that down anymore. So we know we've got our answer. Check this out. When we simplify, no radicands contain fractions. Here's what you can do if you see a fraction all underneath a radical. Just like up here, how we split this into 2, same thing here. You can take that numerator, create a square root with it, take that denominator, create a square root with it. Now, unfortunately, no radicals can appear in the denominator. Ooh, that's a problem. But guess what? The square root of 25 is 5, and the square root of 16 is 4. And we know that's really plus or minus 4/5, which is A-OK. Beautiful. Speaking of no radicals can appear in the denominator, check this one out. This is going to be the toughest one. I know some of you guys have probably done this before, breaking down radicals. You may not have dealt with this before. What we're about to do is called rationalize. About forgot how to spell the denominator. We're going to rationalize the denominator. So you have 6 square root of 2. I'm going to rewrite that. If you want to get rid of this radical, I want you guys to think about this just like if you were trying to destroy a fraction. How do we destroy a fraction? Oh, you multiply by its denominator. Here's the problem, though. If we're going to multiply this fraction, we have to multiply it without really changing it. So to rationalize this, we have to multiply in a way to not change the value. Because if you change the value, this is no longer the same number. So we're going to multiply by the square root of 2. But if you do this to the bottom, you have to also do this to the top. And what do we know the square root of 2 over the square root of 2 really is? Guess what? That's really 1. You multiplied it by 1, which does not change its value. So by multiplying it by that, we're not changing this value. Instead, we're getting rid of that because the square root of 2 times the square root of 2 would be the square root of 4. 6 times the square root of 2. Remember, you cannot put these together in all underneath the radical. This is just a regular number. So boom. Square root of 4. Going to be 2. And be careful here. Take your finger, block that out. We've got 6 over 2. Can that reduce? You bet it can. Plus or minus 3 square root of 2. 6 divided by 2 is 3. This is going to be, like I said, the toughest one. Rationalizing the denominator. Multiplying by the denominator to both the denominator and to the numerator. Okay. I want you guys to try Try 1 through 4 for me, please. See how you guys do on these 4. All right. So we know the square root of 49, that is a perfect square. It's just 7 times 7. So our answer would be plus or minus 7 when we simplified that. Something you guys may have noticed earlier, when you take a square root and multiply it by itself, it ends up just giving you the radicand, the number underneath the square root. Square root of 2 times square root of 2 is the square root of 4, which gave us 2. Well, guess what? Square root of 5 times the square root of 5 ends up giving you 5. In this case, plus or minus 5 when you take the square root. How about this one? These are both perfect squares. So square root of 25, 5, the square root of 9, 3, plus or minus 5 over 3. And then finally, we know we can do the same thing we did before. Make the numerator a radical, make the denominator a radical, and normally this isn't good, but we know 36 will reduce down to 6. Square root of 100 is 10, and don't forget that will reduce 10 over 6. You can divide both those by 2, plus or minus 5 over 3. So guys, this is the end of video 1. We'll either have 1 more or 2 more videos. If we have 3, the third one will be really short. But I wanted to go ahead and give you guys a crash course on radicals, or a reminder for some of us, hopefully. And so I will see you guys in video 2.